Hello everyone, and welcome back to another overclocking basics video, which I have promised to do more of a while ago, and now I'm finally delivering on that promise. So, today I want to talk about memory ranks and bank groups, because both topics are somewhat closely related. So, what are memory ranks? Well, most people probably know what a memory channel is. Like on a consumer board like this, you have two channels. The first channel would be the two left DIMM slots, and the second channel are the two right DIMM slots. You can actually see the numbering scheme down here. But memory ranks is something that most people don't really know about, so that's why this video exists. So, we have two DIMMs right here, and they look very similar like this, but once we look at the back of them, you can see that one of them has memory chips on both sides, and the other one does not. And that's what we're talking about. So, the one stick that doesn't have chips on the backside is a single rank DIMM, and the one that does have chips on the backside is a dual rank DIMM. So, that's, in a very basic way, the difference between single and dual rank. But what really is a memory rank? Well, a memory rank is, if you ask me, an array of memory chips that put together has a total width of 64 bits, because each memory channel is 64 bits wide. Now on this board you can have up to 2 sticks in each channel that share those 64 bits, but when you look at the sticks, you can also have more than one rank per stick that also again shares those 64 bits. So, every time you have enough chips to make up 64 bits, that's a rank. For example, this stick right here, it says 1R times 8. That means one rank using X8 chips. The X8 meaning that each chip on here is 8 bits wide. 8 times 8 is 64, so this right here is one rank. And if we look at the other stick, it says 2R times 8. That means 2 ranks, also using 8X chips, because, well, 8 times 8 is 64, and 8 times 8 is 64. So, we have 2 ranks on this stick. Now, why would you care about that? Well, dual rank is faster. It just is. And there's 2 reasons why dual rank is faster. The first one is rank interleaving. The second one is the number of bank groups that you have. So let's talk about the first one, because it's a bit more simple. Now this is oversimplified. It doesn't really work like that, but in essence, you know, you're gonna understand the principle of what I'm about to say. So, rank interleaving is kinda like hyperthreading for a CPU core. Now you have one stick of RAM, just like you might have one CPU core, and our single rank stick would be a CPU core without hyperthreading, and our dual rank stick would represent a CPU core with hyperthreading, because both of the ranks on this stick can be somewhat independently accessed by the memory controller of our CPU. So the 2 different ranks on the stick can work on 2 different things at the same time, kind of like a CPU core with hyperthreading. It's still one single core, but it can actually do 2 tasks at the same time. And it's similar in essence with a dual rank stick. Each rank can work on one thing at the same time. On a single rank stick, well, you only have one rank, and it only does one thing at the time. So that is reason number 1 why dual rank sticks are faster. And reason number 2 is that a dual rank stick has more bank groups, and that is also where I need to explain bank groups. So here we have another stick. So this is actually a SODIMM stick, that's why it's smaller, but that's not the thing that I want to highlight. What I want to highlight is that, well, this one's also empty on the back, and if we look at the front, there's only 4 chips, whereas our other single rank stick has 8. Just like our dual rank has also 8 chips per rank. So is this only half a rank? No, this is still a full memory rank. This is just using x16 chips. So, instead of having memory chips that are 8 bits wide, this is using memory chips that are 16 bits wide. And that is somewhat of a problem, because 16x chips only have 2 bank groups, whereas 8x chips have 4 bank groups. So, what are bank groups? Well, again, this is oversimplified. Bank groups are basically just the massive arrays of ones and zeros that actually store the data going into your RAM. And they are, again, kind of like CPU cores, but not really. It is just that accessing a different bank group is faster than accessing the same bank group twice in a row. So there's timings called TRRDS, TRRDL, and then there's also other subtimings that describe the amount of time that you have to wait when you want to access different bank groups. And accessing a bank group that is in an idle state is always faster than accessing a bank group that's just been used and still needs some extra time to return to a proper idle state. So if you hit the same bank group twice in a row, you have to wait for it to go back to a full idle state before you can actually do something with it again. Whereas if you access a different bank group, well, it will already be in an idle state because the bank group you just used is a different one. So using different bank groups is faster. The problem being, well, we only have 4 chips on this with 2 bank groups each, which means we only have 8 bank groups on an x16 stick. This also goes for full-size DIMMs. This is not only for SODIMMs. You can also get full-size DIMMs like these using x16 chips. And yeah, these will only have 8 bank groups on them, whereas our single rank DIMM, it has 8 chips with 4 bank groups each, so this has 32 bank groups. That is 4 times more bank groups. And then our dual rank DIMM is even more ridiculous because, well, we have that extra rank, which means we have 16 chips with 4 bank groups each. This has 64 bank groups in it. This only has 8. So that is quite a difference. This has 8 times as many bank groups as this one. So when you use this DIMM versus an x16 DIMM, you have an 8 times higher chance that you will have to wait an extra length of time with this one compared to this one. And that can be quite significant. And that, together with rank interleaving, means that dual rank DIMMs are faster. So, now that we know all that, you may be asking yourself, well, why do x16 chips exist? Why isn't just everything dual rank? Well, there is a reason for everything here to exist. Now, these x16 chips, like you can see here, they're actually on a SODIMM, which goes into a laptop. Now, they could have filled out the back of this, but they didn't, and sometimes you also have RAM soldered directly to the motherboard of a laptop, where it doesn't actually use a RAM stick, it's just on the motherboard, and you may only have space for 4 chips and not 8. In that case, using x16 chips makes sense, because you have a space constraint, and sacrificing some performance to still get a higher total amount of RAM, for a laptop that's worth it. As to why not every single desktop DIMM is dual rank like this one, well, first of all, they are just straight up more expensive. You need twice as many RAM chips, and you need to run this stick through the soldering assembly line twice, because you need to have both sides of it populated, whereas this one has a backside that is completely empty. So it has more components and also needs more time to be made, which just means it's more expensive for the manufacturer and at the end for the consumer. And there's also some performance and specifically overclocking headroom implications of dual rank that are not that great, because, well, you have 2 ranks, that's nice for performance because of rank interleaving and the extra bank groups, but there's one thing in your system that doesn't like that, and that's the memory controller in your CPU. The memory controller only can handle so many chips before it becomes overwhelmed and you have to reduce your frequency or loosen out your timings to still be stable. Your memory controller does reach a point at some point where it just can't handle that many chips. So running dual rank DIMMs for a multitude of reasons, not just the memory controller, there's also other reasons like having a more complex PCB, maybe not having enough layers to have perfect signal integrity on dual rank compared to a single rank DIMM that only has twice as many connections, only half as many connections. Your motherboard may not be optimized for dual rank DIMMs. Like, there are quite a few reasons for this, but in the real world, a dual rank DIMM will overclock to a lower frequency and sometimes also slightly worse timings than a single rank DIMM. Now that is new with DDR4 and DDR5. On DDR3 and DDR2 I've been told that wasn't really a thing, but on DDR4 and DDR5 dual rank DIMMs tend to clock lower and have sometimes not that great of timings. So there is a trade-off here. At the end of the day, a dual rank DIMM is still worth it. The performance will be better. Rank interleaving and extra bank groups does add more performance than the lost overclocking headroom takes away from you. So, in my opinion, dual rank is still worth it. So if you can get a dual rank kit, I encourage you to do so. But I wouldn't throw a single rank kit away like this one. If you have a single rank kit, you know, yeah, you're losing out. You're not getting rank interleaving and you only have half as many bank groups as you maybe could have. But that's not the end of the world. You can manually optimize a single rank kit to be basically on par with dual rank, at least in real world day-to-day usages. If you really want to, you know, exactly measure it with a benchmark, a dual rank DIMM will probably still be faster. Actually, if you go into extreme overclocking territory, there's some benchmarks that actually prefer single rank, but that's outside of the scope of this video. We're talking about real world use, and in real world use, dual ranks usually is faster. But if you spend the time on optimizing a single rank DIMM, you are gonna get to basically within negligible performance difference of a dual rank kit. So you can fix it, it's just that, you know, you need to put in time, whereas a dual rank kit just kind of does all of this for you. So don't throw your single rank kit out just because dual rank kits exist, but, you know, if you are shopping for a new RAM kit or you're building an entire new system, if you can get a dual rank kit, probably should look for one if you can. Now that brings us to one last point. I've been using these WinPCB OEM sticks for this video because, well, they don't have heat spreaders and it's very easy to show what's on them. But, you know, most RAM kits look like this instead. They have heat spreaders. So how do we tell if this is dual rank or single rank? They don't really have those stickers on them that say what they are. Like, the stickers usually only give you a very basic info about what's actually under those heat spreaders. Well, you can still check if it's dual rank or not by just looking under the heat spreader and seeing if both sides have chips on them. In case of this one, we can see that there's chips on this side. You can just about see the little BGA connections under the chips, and on this there are some components, but no chips. Only chips on this side. So this is single rank. And there's actually an easier way of finding out if your stick is dual rank or single rank. You can just boot up your system, download CPU-Z, go to the SPD tab, and then just read the SPD profile of your stick, and that will tell you if it's single or dual rank. But what about sticks that you haven't bought yet? Maybe you are about to order something online and you really want to find out if it's single or dual rank. That is a bit of a problem. So in some cases, you can tell what it is. Like if you buy a 2x16 kit that uses a Samsung 8GB B-die XMP, then it has to be dual rank because 8GB B-die, well, it's 8 gigabit. 8 of those chips only make 8 gigabytes, so it has to be dual rank. But, you know, that's just one very specific example. If you buy used, you could ask the seller to just check CPU-Z for you. But if you buy new online, you can't really always tell. If you go for some super high capacity, then that's usually dual rank, because, you know, especially for DDR5 right now, super high density chips don't really exist yet, so there's a fairly high chance of you getting a dual rank kit if you just go for some super high capacity. But that also has problems with it again, because those are very expensive. And that kind of leaves us at a point where just like, yeah, there's not really a way to tell if a kit is dual rank or not. So yeah, you can put in the effort and, you know, ask around and like maybe find people who have the same kit and just have them tell you what they got. But there's really no universal 100% reliable way to find out if a kit that you are about to order online is single or dual rank, which is a bit of a bummer. And yeah, like again, at the end of the day, it's not the end of the world if you get a single rank kit. It's just that having a dual rank kit, it just gives you free performance, and it's very slightly always better than single rank, you know, if you really want to go for the every last percentage out of it. But that's gonna be it for this video. I hope you learned something from this. There's probably gonna be more overclocking basics videos soon again. And until next time, goodbye.